Welcome back to the beginning of Chapter 6. In this chapter, we are going to start looking at exponential functions. But before we get there, we're going to look at some rational exponents and properties of exponents. That's what we'll be doing today. Our learning targets: I can use properties of exponents to solve equations with rational exponents. So we'll see the properties of exponents, solve equations with rational exponents. Rational means it can be written as a fraction. So we're going to start having exponents that are fractions, and we'll see what that means in just a second. But first, let's take a look at just exponents and some properties of exponents in general. So exponents is repeated multiplication. So if we have 2, well, that's just 2 to the first. It's 1, 2. 2 times 2 is going to be 2 to the second because it's 2 2's. 2 times 2 times 2 is 2 cubed, etc. If we have 17 2's multiplied together, that would be 2 to the 17th. That's what exponents mean. We have some properties that go along with them. First of all, we have the product property. And what the product property says is if we have a to the n times a to the m, we would end up adding those together. So we'd have a to the n plus m. Notice the base is the same for these. And so what this says is if we had 2 to the 5th times 2 to the 7th, well, 2 to the 5th is 5 2's multiplied together. 2 to the 7th is 7 2's multiplied together. If we multiply those together, we just have a string of 2's, right? Because this 2 times 2 times 2 times 2 times 2 times, so that was 2 to the 5th, times then 2 to the 7th, was this multiplication sign any different than any of the others? No. So this, we just have 5 2's plus 7 2's is 12 2's just multiplied together. And so that's what that product property says. We also have a quotient property. We have a to the m over a to the n. And well, when we're multiplying them, we add the exponents. When we're dividing them, we subtract the exponents. And where this comes in, let's say we have 2 to the 5th over 2 to the 3rd. We could expand this. 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2. And then we can simplify. 2's divided by 2 is 1. Is 1. Is 1. And so we end up with 2 squared, which was 5 minus 3. So these properties allow us to do it without having to expand it all out. Now we also have a power property. So we have the product property, the quotient property, we have a power property. And that is if we have a to the m to the n. What happens here is we end up multiplying the powers. And the way that would work is if we had, let's say, 2 to the 5th to the 3rd. Well, the exponent to the 3rd means we just have 3 of these. So that's 2 to the 5th times 2 to the 5th times 2 to the 5th, which can then go to the product property, where we would just add these together. That's 5 plus 5 plus 5 is 5 3 times. That's what multiplication is. And so that's how that power property works. And then one more, so we have the, let's see, the product property. I've simplified names. This is actually the product of powers, the quotient of powers, the power of powers. But let's see, so we have the product of powers. We also have the power of the product property. There's lots of P's. So these are all whatevers of powers, but then we have the power of a product property. And what that says is if we have, say, A times B to the M. So notice everything else, we've always had the same base for all of these. This one, we have two things multiplied together, both being taken to a power. What we can do here is we can actually distribute that power to both of them. So let's say we had 2x to the third. That's just 2x times 2x times 2x, which could be rearranged 2 times 2 times 2 times x times x times x because of the commutative property of multiplication. And then 2 times 2 times 2 is 2 to the third. X times x times x is x to the third. So we can distribute that power through multiplication. Now, if this was a plus b, you cannot do that. But with multiplication or even division, if we have a over b to the m, that'll be a to the m over b to the m for the same reasons. So we have these properties, which we are going to be using. So now, talked about rational. So what does 3 to the 1/2 even mean? What does it equal? Well, so let's see. We have 3 to the 1/2. It'll equal something. Let's give that a name. Let's call it x. So, well, what could we do? We could square both sides of this equation. So let's go 3 to the 1/2 squared equals x squared. And we do that because when we have that power of a power, the property we just saw, 1/2 times 2 is going to be 3 to the 1 equals x squared. Well, so x squared equals 3, so what times itself is going to equal 3? And that would be the square root of 3. So what does 3 to the 1/2 equal? 3 to the 1/2 is the square root of 3. And in fact, that's going to be true for anything. If we have a to the 1 over n, that's going to be the nth root of a. So those denominators give us the roots that we'll take. So the nth root of a would be what we'd have to multiply n times to get a. And this can be generalized even further. A to the m over n, that's the top of the fraction, the numerator, is the exponent. The denominator is the root. So we'll have, this would be the nth root of a to the m, or this could also equal the nth root of a all to the mth power. So if we wanted to do an example on something like this, we could have, like, say, 8 to the 2/3. Now, And so we're going to simplify. We could take 8 and square it, and then find the cube root, or we could do the cube root and then square it. What's the cube root of 8? Well, if we do a factor tree, we get 4 times 2 and 2 times 2. So 8 is just 2 cubed, which means the cube root of 8 is just 2, and then we square it to get 4. So that's how those denominators work in your exponents. They make the root. So here we have 2 multiplied by itself 3 times gives us 8. So the cube root of 8 is 2. So solving equations, we can use these and the properties to solve some equations. So if we have something like this, x to the, or 3 to the x over 2 times 3 to the x over 3 equals 3 to the 9th, we can solve it and get an answer. When we solve an equation, remember our answer is going to look like x equals something. Now, this is going to be a lot easier than what it looks like, because right now, it's looking really ugly. But it will be easier than that. The first thing we want to do is we want to combine our 3 to the x over 2 and 3 to the x over 3. They have the same base. We're multiplying. When we multiply, we add exponents. So this will be 3 to the x over 2 plus x over 3 equals 3 to the 9th. Don't lose that equal sign. You have an equation. You should always have that equal sign there. To add these two exponents together, we're going to need common denominators. That would be a common denominator of 6. So this would be 3. That'll be, see, we'd multiply by 3. So we have 3x over 6 plus multiply by 2, 2x over 6 equals 3 to the 9th. And so this is 3x plus 2x is 5x over 6 equals 3 to the 9th. Well, if 3 to one power is equal to 3 to the other power, wouldn't that mean that the two powers have to be equal? In order for this side to equal 3 to the 9th, that means that 5x over 6 has to equal 9. So once we have a base to a power equals that same base to a power, the powers have to be equal. And now we can solve this. So let's start by multiplying both sides by 6. So we have 5x equals 9 times 6 is 54. And then we can divide by 5 to get x equals 54 fifths, which if you really felt the need to, you could write it as 10 and 4 fifths if you wanted as well, although 54 fifths should be sufficient. So to solve this, again, what we did was we used that product property. So we combined it, we added the exponents, we needed a common denominator, and then once we had 3 to a power equals 3 to a power, the powers had to be equal. And then it was a fairly simple linear equation to solve. So here's another one that's almost identical. Right? Try this one. Push pause, work this one out in your notes on a piece of paper. See if you can do it, and then we'll go over it. All right? So push pause and come back as soon as you're ready. All right, did you do it? Well, let's see. So when we add, or when we multiply, we're going to have 2 to the x over 4 plus x over 6 equals 2 to the third. Combine our fractions means we need common denominators, which could be 12. So this is 3x over 12 plus 2x over 12 equals 2 to the third. When we add these, 3x plus 2x will be 5x over 12 equals 2 to the third. So we have 2 to a power equals 2 to a power, which means 5x over 12 will have to equal 3. We can multiply by the 12 to get 5x equals 36, and then divide by 5 to get x equals 36 fifths. You could go 7 and 1/5 if you need to, but I would leave it in the improper state. So, how did you do on that one? See how it was basically the same? Notice all of the bases were the same. That's very important. All the bases have to be the same for us to do this. So, what if the bases aren't the same? Well, we need to make them the same. So 27 is 3 to a power. 27 is 3 cubed. So we have that. Now we can use our power property. Remember, when we have powers of powers, we multiply. So we'll have 3 to the 3 times x minus 4. Make sure that we distribute. 3x minus 12 equals 3 to the 2x minus 6. Now, once again, we have 3 to a power equals 3 to a power, which means 3x minus 12 has to equal 2x minus 6. And now it's a linear equation. We can move the x's to one side. Let's subtract 2x, subtract 2x, move the numbers to the other side. So we can add 12, add 12. 3x minus 2x is just x equals negative 6 plus 12 is 6. So x equals 6. Another very similar problem is 1 over 25 to the negative x over 2, and 1 over 25 to the negative x over 3 minus 2. So we have 1 over 125 isn't really 1 over 25 to a power, but these can both be written as powers of something, right? 25 is 5 squared. 125 is 5 cubed. To get the 1 over, that's just the negative. So 1 over 125 is 5 to the negative 3 to negative x over 2 equals 1 over 25 is 5 to the negative 2 negative x over 3 minus 2. So now we can multiply because we have power of powers. This will be 5. Negative 3 times negative x over 2 is positive 3x over 2 equals 5 to the, we can distribute this. Negative 2 times negative x over 3 is 2x over 3, and then plus 4, which means 3x over 2 has to equal 2x over 3 plus 4. We can subtract to get our variables on the same side. We're going to need common denominators. So of 6, so multiply by 3, so this will be 9x over 6 minus, multiply by 2, 4x over 6 equals, we have 4 left on that side. So 9x over 6 minus 4x over 6 is going to be 5x over 6 equals 4. We can multiply by 6 to get 5x equals 24, and then divide by 5 to get x equals 24 fifths. So in this case, we had to change both sides so they're the same base. As in the first one, we only had to change one side so it was in the same base. The fact that it was 1 over and they need to be negative was just an extra thing there. We could have had in that top one 27 x to minus 4 and then 9 to the 2x minus 6, where we would have had to change both of them into 3's. So here's another couple to try. Go ahead, pause this, try these in your notes, see if you can do them, and then come on back when you're ready. All right, are you ready? So this first one, 256, it's a bigger number to deal with. 256, well, I know it's 16 squared, and 16 is 4 squared, so 256 will be 4 to the third power, or to the fourth power. It could also be 2 to the eighth power if you went for 2's, but it's 4 to the fourth power, x plus 2 equals 4 to the 3x plus 9. So if you change them both to 2's, you would do the exact same thing, except that your numbers would just be a little bit bigger when you're working the problem, but it would work out the same. A power of a power, we multiply, so we'll have 4 to the 4x plus 8 equals 4 to the 3x plus 9, which means that the exponents are equal. We can subtract, move the x's to the same side, and move the numbers. So here 4x minus 3x is x equals 9 minus 8 is 1. And then this other one, we have 1/8 and 1/4, so 8 and 4. Those are both powers of 2. 8 is going to be 2 cubed, so this will be 2 to the negative 3 to the x over 2 minus 1 equals 4 is 2 squared, so I have 2 to the negative 2 x over 3. We can distribute those exponents. 2 to the negative 3x over 2 plus 3 equals 2 to the negative 2x over 3. And then the exponents can be equal because they're to the same base. So we have negative 3x over 2 plus 3 equals negative 2x over 3. Let's move the variables all to the same side. Because all the numbers are already right here. So we'll have 3 equals. We'll need common denominator. So a 6, so times 2, so we have negative 4x over 6, and times 3 plus 9x over 6. We add those. We'll have 3 equals 5x over 6. We can then multiply by 6 to get 18 equals 5x. Divide by 5. And we get x equals 18 fifths for this one. So we can use these properties. This was using the power property more than the product property, but we can change the base, then we multiply, and then we get it so it's the base to a power equals the base to a power, and we can then solve from there. So we have a couple application type problems. So Adam is setting up an outdoor concert. He places 3 square blankets near the band as shown in the picture. What is the area of blanket C? So blanket C is x yards squared, which since it's a square means that we're going to have our side lengths are going to be root x, or x to the 1/2. And then same thing, the blanket B is 8 square yards, So that means that we'll have the square root of 8, or 8 to the 1/2, for those side lengths. Well, if we look at this rectangle, the area of that is gonna be the side times the side. So we have 12 will equal 8 to the 1/2 times x to the 1/2. Well, using that, the product of powers property, power of products property, the last one that we looked at, the one that was in that bottom right-hand corner, we're going to use it the other way. Instead of distributing the power, this is 8x to the 1/2, right? Because properties work both directions. So we have 8x to the 1/2. It would be great if that wasn't to the 1/2. So we can do, if we took that and squared it, the 1/2 times the 2 would give us just a 1. Well, if we square that side of the equal sign, we have to square this side of the equal sign as well. So we have 12 squared, which is 144, equals, those two exponents end up just being 1, so that's just 8x. And then we can divide by 8 to get x equals 144 over 8 is 18. So blanket C, the area of blanket C is 18 square yards. So we set it up. In this case, we were able to kind of put the 8x together under that one because we factored out the 1/2 in essence, but using that property. Similar here, we have terrarium A and terrarium B are cubes. The side length of terrarium A is twice the side length of terrarium B. What is the value of x? So a side length, we have volumes. The volume of a cube is a side cubed. So to get back to a side, we'd have to do the cube root, or go to the 1/3 power. So we have 2 to the x to the 1/3, and 2 to the 1/3 would be the side lengths. Now it tells us that the length of terrarium A is twice the length of terrarium B. So if we divide them, that means it would be 2, or we could do 2x to the 1/3 equals 2 times 2 to the 1/3, but let's divide instead. So the big one divided by the little one will have to equal 2 because it's twice the side length. So we can do the multiplication here. We have x times 1/3 will be 2 to the x over 3, or 1/3 x, over 2 to the 1/3 equals 2. We're dividing. When we divide, that means we subtract exponents. 2 to the x over 3 minus 1/3 equals 2. They even have a common denominator already. Let's combine it with a common denominator. X minus 1 over 3 equals 2. All right, well that's 2 to the 1. Remember, if there's no exponent, it's to the 1. We have 2 to the something equals 2 to the something. That means that x minus 1 over 3 has to equal 1. So to solve, we can multiply by 3. That was supposed to be blue. So we have x minus 1 equals 1 times 3 is 3, plus 1, plus 1. So x equals 4. So it's asking for what is the value of x. X equals 4. So um, that's just another example of some application, how we can set it up, how we can use that quotient property to subtract. This one also uses the power property because we had to do that. In addition to the idea that if a side length is twice, we can divide and get 2. So today we had a few properties of exponents, like what are exponents? And then we had the product of powers property. We had the quotient of powers property. We had the power of powers property. And then we had the power of product property. Um, so, and then the idea of the rational exponent, where we have a denominator in the exponent, gives us a root for that. So this is what we're working on, this section. We'll get into what what they look like as functions and graphs in the next section. So I will see you in class. Until then, keep working problems, keep asking questions, and as always, happy mathing.